Hello and welcome to this video where we are going to learn about circle theorems. First, let us know the names of the parts of a circle. Center. This is the center of a circle where all the points on the circle are at an equal distance from this point. Next, radius. Now, if you draw a line from the center to any point on the circle, this line is called the radius. The radius is same for all the point on the circle. Next, if we extend this line across the circle passing through the center, we get the diameter. The diameter is always twice the length of the radius. Next, a chord is a straight line segment connecting any two points on the circle's circumference. The longest possible chord of a circle is its diameter. Next, sector. A sector is always bounded by two straight lines that extend from the circle's center to its edge. A sector with a central angle less than 180 degree is known as a minor sector. A sector with central angle greater than 180 degree is known as the major sector. Arc. The curved edge of the sector is part of the circle's circumference, is known as an arc. A minor arc is the shorter, smaller arc connecting two points on a circle's circumference, subtending a central angle of less than 180 degrees, or simply the arc in the minor sector. This part is longer and the central angle is greater than 180, so this is a major arc. If your chord divides the circle into two regions, each region is called a segment. The segment with the smaller area is known as minor segment, and the segment with the larger area is known as the major segment. The circumference of a circle, which is same as its perimeter, is the total length of the boundary of the circle. Next, a tangent of a circle is a straight line that touches the circle's circumference at exactly one point. Next, the word subtended is used in the circle theorem to describe how an arc or a chord creates an angle at a point on the circle. When an arc forms an angle at the center, we say the angle subtended at the center by the arc. And when the arc forms an angle at the circumference, we say the angle subtended at the circumference by the arc. So far, we have seen the names of parts of a circle. Now let's look into the circle theorems. The first theorem is the angle subtended by an arc at the center is twice the angle at the circumference. If this angle is 2x, that is the angle subtended at the center is 2x, then the angle subtended by the same arc at the circumference is x. Suppose if the angle at the center is 90 degree, then the angle at the circumference is 45 degree. So here also it is 45. Here also it is 45. If it is kept here also, it is 45. Suppose the angle subtended at the center is 85, then the angle subtended at the circumference is 42.5 degree. So if the angle extended at the center changes, the corresponding angle extended at the circumference also changes. And if you change the angle at the circumference, then the corresponding angle subtended by the same arc at the center also changes. Let's look into this example. A, B and C are points on the circle, center O. DE is a tangent to the circle at C. Angle ABC is 70.2 32 degree. AC is 10 centimeter, AB is 9.5 centimeter, and BC is 7.7 centimeter. Find the angle AOC. So we need to find the angle AOC. So the given angle is ABC is 70.2. This is 70.2. Then what is the angle at AOC? That will be twice the angle at the circumference. Angle at the center will be twice the angle at the circumference. So angle AOC is twice 70.2, which is 140.4 degree. The next theorem is the angle in a semicircle is a right angle. Now let's change the angle between B and C to 180 degree. So angle at A will be 90 degree of that. So it will become 90 degree. Now BAC forms a semicircle. So angle in a semicircle is a right angle. Let's look into this question. AB is the diameter of a circle, center O. C is a point on the circle and the angle BAC is 52 degree. Find the angle ABC. So we know that the angle in a semicircle is 90 degree. Angle in a triangle is 180. So angle ABC is 180 minus angle at A is 52. Angle at C is 90. So this is angle at ABC. Which is 38 degree. So angle at B is 38. The next theorem is angles at the circumference subtended by the same arc are equal. Here the angle subtended at the circumference at A is x degree. Then the angle subtended by the same arc on the circumference of the circle at D is equal. That is same x degree. If the angle at A is 33.5, then the angle at D is also the same 33.5. If we change the angle at A, the same way angle at D also changes. Let's look into this example. The points P, Q, R and S lie on a circle with a diameter PR. Work out the size of the angle PSQ, giving a geometrical reason for each step of your working. Let's mark the angle at Q, which is 90 degree, because angle in a semicircle is 90 degree. So in triangle PQR, the sum of the angles in a triangle is 180. So the angle at R is, that is angle PRQ. 180 minus 90 minus 29, which is 61. So this angle is 61. So what is the angle at S? This is also 61. Because the angle at the circumference subtended by the same arc are equal, the arc PQ makes an angle at R. The same arc makes an angle on the circumference of the circle at S. So these two angles are same. So angle PSQ is same 61 degree. The next theorem is triangle with two radiuses are isosceles. Here OB and OC are radiuses. So OB and OC are equal. So this is an isosceles triangle. That means angle at B and angle at C are equal. And here the angle at B is 30.6, so angle at C is also same. So if you change the angle at B, the corresponding angle at C also changes. Let's solve this example. A, B and P are points on a circle, center O, and angle OBA is 38 degree. Find the angle APB. Here OB and OA are radiuses. So the triangle OAB is an isosceles triangle. So the angle OAB is also 38 degree. Sum of angles in a triangle is 180. So the angle at O will be 180 minus 38 minus 38, which is nothing but 180 minus 76, which is 104. So this is angle AOB is 104. Next, we will apply the theorem. The angle at the center is twice the angle at the circumference. So angle at the circumference, that is APB, will be 104 divided by 2, which is 52 degrees. The next theorem is radius and tangent meet at a right angle. O is the center of the circle. Let's draw a tangent which touches the circle at a point P. Okay, if you join the point P and O, which is nothing but the radius, okay, so it makes an angle 90 degree. If you draw a tangent at other point where it touches the circle, suppose say I'm drawing a tangent here, let's mark the point of contact of the tangent with the circle. Now let's join P and O. Now it makes an angle 90 degree. The tangent and the radius makes an angle 90 degree. Let's solve this example. The diagram shows a circle, center O, with a diameter AOB. The line CDE touches the circle at D and angle DOB is 74 degree. Write down the mathematical name of the line CDE. The line CD is nothing but a tangent. Next, work out ODB. So here OD and OB are radius of the circle. So the triangle ODB is an isosceles triangle. So angle at D and angle at B are equal. Let me mark this as X. Sum of angles in a triangle is 180. 74 plus X is 180. So 2x is 180 minus 74. So then what is x? 106 divided by 2, which is 53. So angle ODB is 53 degree. Now next part of the question is work out the angle BDE. So now we need to find this. Okay. So this is 53. CDE is a tangent which touches the circle at the point D. So the angle between the radius and the tangent is 90. So this is 90. Okay. So 90 minus 53, you will get this angle. Angle BDE, which is 37. Angle BDE is 37 because radius and tangent meet at right angle. The next theorem is two tangents from the same point are equal. In the circle, O is the center. Let's draw two tangents. P1 and P2 are the point of contact with the circle. OP1 and OP2 are radius of the circle. We know the tangent and radius make an angle of 90 degree. So let's mark it. The two tangents meet at the point C. Now the distance between C and P1 is same as the distance between C and P2. Let's solve this question. A, B and C are points on a circle center O. DA and DC are tangents. Angle ADC is 44. Work out the value of x. To find the value of x, let's first find the angle at O. So here OA and OC are radiuses. So angle at A will be 90 because tangent and radius meet at right angle. So angle at C is also 90 degree. So angle DAO is 90 and angle DCO also 90 degree. In a quadrilateral, the sum of angles is equal to 360. By using this theorem, let's find the value of angle at AOC. So 44 plus 90 plus 90 plus angle AOC is equal to 360. So angle AOC is equal to 360 minus 44 plus 90 is 224. So minus 224, which gives 136. Okay, so the angle at AOC is 136. Next, angle at the center is twice the angle at the circumference. So x is 136 divided by 2, which is equal to 68 degree. The next theorem is angle between the tangent and a chord equals angle in alternate segment. So here we have a circle with tangent and chord and two alternate segments. Then the angle between the tangent and the chord, which is equal to the angle in the alternate segment, which is the angle at here. Suppose if the angle between the tangent and chord 48, then the angle in the alternate segment is also 48. If we change the angle between the tangent and the chord, okay, see the corresponding angle between the alternate segment also changes. Okay. If we make the angle between the tangent and the chord 90 degree, we see that the angle in the alternate segment is 90 degree. So which is nothing but the angle in a semicircle is 90 degree. Let's solve this question. Points E, F, G and H lie on the circle and EG is equal to EH. HF and EG intersects at K. ET is a tangent to the circle at E. Angle FET is 47 degree and angle FEG is 25 degree. Find the value of X. Here it's given EG is equal to EH. So in triangle HGE, two sides are equal. That means it's an isosceles triangle. So angle at H is equal to angle at G. Okay. So if you consider this chord EG, it makes an angle with a tangent which is 25 plus 47, which is equal to 72. So the chord makes an angle 72 with a tangent. Okay, this is equal to the angle it makes with the alternate segment. So the alternate segment is here. So H, angle at H is 72, which is same as angle at G. So this is also 72. Okay. In a triangle, the sum of the angle is 180 degree. So if you add X with 72 plus 72, it is equal to 180. So what is X? X equal to 180 minus 72 minus 72, which is equal to 36. So angle at X is 36. The value of X is 36. The next theorem is the perpendicular bisector of a chord is a radius. In the circle, AB is the chord and O is the center. The perpendicular of the chord is a line segment drawn from the midpoint M of AB to the center O. If the radius intersects a chord in a circle, it will bisect the chord at a right angle. Bisect means cut into half. If we take any chord in a circle, the perpendicular bisector of the chord is a radius. Let's solve this question. A, B and C lie on a circle, center O, radius 8.5 centimeter. AB is equal to BC equal to 10.7 centimeter. OM is perpendicular to AB and ON is perpendicular to BC. Write down the length of MB. So it's given AB is 10.7 centimeter. OM is perpendicular to AB. That means OM intersects the line AB and the midpoint. That is, it bisects the AB at M. Bisects, so 10.7 divided by 2, which is 5.35. So AM is 5.35 and MB is 5.35.